Hello everyone, I'm Mark and we are just going to have a short video today to show you the results of an experiment that was done yesterday on Facebook, uh, as well as to draw one winner of a 1000 gem code from the people who participated in that experiment. So what is the experiment? So as we all know, the Forgotten Realms set is going to be released sometime this week. Really fired up to draft that set. And one of the mechanics in the new set is to die roll. So there will be plenty of cards that will ask you to roll a 20-sided die or a d20. And so one issue that has come up is that d20s, 20-sided die that are meant for rolling, are different from spin down life counters like the one you see here on this uh, page, on this Excel sheet rather. So we wanted to see if, well, just how different that is for people who are not trying to cheat their die rolls, right? So we know the difference between a D20 and a spin down. That part is clear. So when you have a spin down, as you can see here, the numbers are not randomly arranged around the die, or rather they're not arranged in order to make sure that each section of the die is similar to the other sections in terms of the sum of the numbers on that section. So obviously, if you are using a spin down dice, there will be a half that has all the high numbers and then another half that has all the low numbers, which does make it a bit easier for you to kind of cheat your die roll. So spin downs are not used for actual D&D tournament play, or so I've heard, because I don't do actual D&D tournament play, but so I heard. And for the new Forgotten Realms set, we're about to receive a rule. Probably that rule is going to state that you should only be using D20s for game rolls involving dice. For the rolls that are for cards that involve die rolls rather. Okay, but like I said, we wanted to just try it out and see if a person who is not intending to cheat would actually get results from a spin down that are similar to what they would get if they were spinning a fair die. Right, so how do we do that? So if you are spinning a fair die, then the average value, a fair 20-sided die, then the average value of your spins would be about 10.5, right? That's the average of all the numbers on the die from 1 to 20. All right, so uh, this is the experiment that we asked people to do, to throw a spin down dice at least 50 times and get the average of the results. And we expect the average to be about 10.5, right? And since we are doing this 50 times, then the variance, so of course for a fair 20-sided die, then we know that that is uniformly distributed from 1 to 20, and therefore we can compute the variance for such a random event given here. You can see variance equals n squared minus 1 over 12. So that is exactly the value that you see here. And so the standard deviation is just the square root of that. And therefore, we can compute our 95% confidence for the margin of error, assuming normality, which we can because we are doing this 50 times on the average, and so we can use the central limit theorem to say that it's going to be normal. And so the distribution of the average, I mean, is normal. And so the margin of error from this experiment computed here is about 1.6. So what does that mean? It means that you expect that whatever you get, right, this is before you do the experiment, right? Your margin of error is 1.6. And that means that before you do this experiment, you expect your actual estimate to be off from the true, you can expect it to be off from the true value by about 1.6, which is okay. I mean, we don't need to be very, very accurate for this experiment. It's only alarming if someone's average is like 15 or 14, something like that, because then even with the margin of error, we can see that it's very high or very low average roll compared to 10.5. All right, so we had 1, 2, 3, 4, 5, 6, 7, right? 7? Yes. 7 people who participated in this experiment, and we can see the results of those people here. And as you can see from the results, none of the outcomes were alarming. All of these are fairly what you'd expect, which does seem to show that spin downs do not provide a natural advantage to die rolling unless you are actually trying to cheat. Right, and that can be an experiment for another time. I am thinking of an experiment that involves that, like asking people if they can actually provide evidence that they can roll a spin down dice to get a high result every time without looking obvious, without looking like they're actually cheating. Right, that would be an interesting experiment for another time. However, take note that this result does not mean that you should be rolling spin downs at the pre-release. No, please do not do that. Especially if there is already an official rule where you should be using a D20. And take note that for the pre-release kits are supposed to contain actual D20. So you really don't have an excuse to roll a spin down because you will be provided with a D20 with your PR kit. So the rule remains that you must use a D20 for purposes of die rolling in relation to the new set's mechanics. And that is it for our results. So now let's draw a winner for a 1000 gem code from among these people who participated in this experiment. So right now I have these blocked out so you can't see the actual numbers. If you look at the formula bar, you'll see that it's just a formula, right? This makes my die rolling a lot easier. I mean, my random selection a lot easier. So that means that that function rand generates a random number from 0 to 1, a continuous uniform random number, whereas we were dealing here earlier with a discrete random number. All right, so all I need to do is to spin it by pressing delete or any other key on any other cell, and that will automatically change these numbers. So we will give it a few spins, and then the person with the highest value, right? The person with the highest value after a few spins here is going to win the 1000 gem code. Spinning, 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 spinning. All right, that should be enough. So now I'm going to copy these values, paste special as values so that they will no longer change. Now they've become actual values. Now let's take off the blinds here. And who has the highest? Oh, it's close. So the winner, I believe, is Frank Saint Laurent. Let me just make sure. We sort it by column B from largest to smallest. Yes, and the winner is Frank Saint Laurent. So Frank, you have won a 1000 gem code. I will message you on Facebook with the code. Thank you for everyone else for participating, and this may the shuffler be with you always.